So let me explain the concept of double-ended queue. See, first circular queue and then so both will be same. Circular queue first. In linear queue, there is a small limitation. We have already seen. Suppose this is the linear queue. In that linear queue, front value is always fixed. So as front location is fixed, if elements are there, so whenever you are deleting the first element, we need to shift all the elements to forward direction. Nothing but all the elements should be relocated. All the elements should be relocated. That shifting of elements taking so much of time. That's the reason they introduced the concept of circular queue. Introduce the concept of circular queue where front location is not fixed. So whenever we shift, whenever you are deleting the element, front location also will move. Front location also will move. Front is not fixed. So here, front value starts with a 0, is a fixed one. Rear value starts with a -1 because it will change anyway. But here it is a both. Front value starts with a -1. Rear value also starts with a -1. Rear value also starts with -1. Here it is. I'm taking 0, 1, 2, 3, 4, 5, 6 is a 7. 6, 7. So this is how the representation of circular queue. How can we perform insertion operation, deletion operation, and display operation? I'll explain. Display operation, all I'll explain. Right. Here is whenever we are performing that operations, whenever we performing the operation, how can we perform? First of all, we are creating one circular queue. Every time I use that circular queue with that size, same size 8 I am taking. 8 I am taking. In this one, 0, 1, 2, 3, 4, 5, index 6, 7. Initially, front and rear values pointing to, for further use, I am using this for further use. Now, initially that front value is a -1 and rear value is a -1. Front is -1, rear is a -1. We are inserting. So any condition you can use. Either front is -1 you can use or rear is -1 you can use. Simply see, you can say that Q is empty. Q is empty. Better directly, I will write the code for both to understand. One is a insert element. Second one is a delete element. For both, I will write the code at a time. One is insert element, whatever the element you want to insert, whatever the element you want to insert. Second one is a delete. What is the item you are going to delete? Delete was always a front item only. Front item only. The first thing is what? How can we check that? Queue is empty. See, as soon as you have taken that queue, queue is empty now. Queue is empty. So if either front you can check or rear you can check anything. Sir, deleting from front now. So I will check front. If front equals to -1, then simply we can say that its queue is empty. Queue means what? You can take a circular queue. Circular queue is empty. If not, else. And in the same way, whenever we are writing that code for insertion also, first what we have to check? If some information that is representing what? Queue is a full, but still not yet. Else, we are inserting. Hope you got it. It's a basic thing. Okay. Now we are doing the first insertion. When we do the first insertion, see, rear equal to -1 means what? Nothing but rear is not pointing to any location. Rear is not pointing to any location. So if rear is not equal, equal to -1 means what? It's not pointing any location. By that time, this is very, very important. Make front as well as rear. Both you make it 0. Make front equal to 0 as well as rear equal to 0. Front equal to rear equal to 0 you can write, or front comma rear equal to 0, 0 you can write. Simple way. Got it? Sir, why? Because of front you move now. Because whenever you insert, it has to pointing to that location, and front is not fixed. Simply into Q, nothing but I'm using CQ, consider, into CQ of rear, that element you are inserting. Look at this. Whenever front and rear both are minus minus, make front value 0, make rear value 0, and insert the first element. Insert the first element, suppose 10. Remember, only at this point. Only at this point means what? Now Q has how many elements? Sir, only one element is there. Nothing but that is the last element. That is the last element. When front and rear become equal means what? When the Q has only one element. When the Q has only one element, then it is called last element of the queue. Suppose if you call delete, that front element delete now. See, if this is last element deletion, by that time only front value and rear value become equal. Not 0, 0, any location. In any location while deleting or inserting, I'll show you in the middle also, then you will get clarity. Front and rear is nothing but you are going to say that it's deleted. So what is the item deleted? CQ of front, CQ of front item deleted. And as usual, make that front and rear -1, -1. Because you need to take it to that as usual positions, starting positions, starting positions. That is, and this one directly you can write like this also. Directly you can delete or make arrangements. First you delete, then you arrange. I'll show you. Look at this. Only first insertion and first deletion we are doing here. First insertion and first deletion we are doing here. If no elements are there, is called it is empty. By that time, rear equal to -1. You can say that front equal to -1 also we can do, but insertions means normally we use the words from the rear. Deletions means what? Normally we use the word from the front. Deletion checking, insertion checking. That is. At if has only one location. Sir, one location means is it zero? Sorry, is it zeroth location? Nah? My mistake. Yeah, yeah, sorry. Zeroth location. Better I use zeroth location. Next one is else if when it reaches that end, that I'll explain. Next one is a else. Now, what is the purpose of else? What is the purpose of else? If block done, this is for first element insertion. Else if is a last element, seventh location insertion. Is else means remaining elements insertion. In all the remaining things, just rear value will increase. Rear value will increase. Nothing but rear value become 1 and increase the value into rear 20 is a 20. Next, rear value 2 is a 30. Rear value 3 is a 40. Is a rear value 4 is a 50. Rear value 5 is a 60. Is nothing but we keep on writing that rear equal to rear plus 1. That's it. And CQ of rear is the same way. Is a CQ of rear. This one. This one instead of writing this, this one, you can write for all only one time. For all, you can write only one time instead of writing these many times. After doing all these operations, just inserted. Just inserted is a 1. But what we are doing here, rear equal to rear plus 1. Rear plus 1. So first it will execute only when front value 0, rear value 0. Remaining all, it will go. Sir, suppose keep on inserting. It will go to 6 is a 70. It will go to 7 is a 80. Sir, Q is full. Q is full. Okay. Q is a full means what? Here, observe this. Front value is 0. Not only check rear equal to size minus 1. Front also, because there in linear Q, front is a fixed. But here front may move. That's why the situation we need to check if front equal to 0 and rear is equal to size minus 1, because size is a 8. Size is a 8. So here, if front equal to 0 and rear equal to size minus 1, rear equal to size minus 1, we can say that Q is a full. This is one situation only. This one more situation is there that I'll explain. This is only one situation. Q is a full. Whenever you are inserting like this, whenever it reaches that, it's a Q is full. Sir, next. I'm deleting. I want to delete. Same story. Here also, else if option is there. And here also, else option is there. Else option is there. Now I want to delete. Always front element only. Now deleting this 0th location element. See, this is the one. Deleted. Front and rear both are not equal now. Yes, not equal. Front is 0. Rear is a 7. So after deletion, this will execute. Front equal to front plus 1. So now front value become 1. Front value become 1. Sir, again I am deleting. Front value become 2. Front value become 2. Again I am deleting. Front value 3, front value 4, front value 5. Here it is a front value 5. Is the elements deleted? Nothing but every time front equal to front plus 1, front equal to front plus 1, like this executing. I'm just removing this, removing this, removing this, because anyway deleted, is anyway deleted. Now look at this. Is it Q is full? No. Normally in linear Q, we write only rear equal to size minus 1 to check this Q is full. To check this Q is full. But now we are not writing like that, because we are checking front also 0. Now it is Q is not full because front is not 0 now. Only rear is a size minus 1, but this is failed. So Q is not full because is there to insert the data. Now observe this. Now observe the first one fail. The first one fail. Front equal to, rear equal to minus 1 condition false. Second one, look at this. Whenever you keep on inserting like this, now it should not execute rear equal to rear plus 1. Why? Because 7 equal to 7 plus 1 means what? It will be 8. It will be 8. So 8 should not happen. 8 should not happen. Again, it should come to 0th location. So is nothing but whenever rear value reaches size minus 1 at the time of insertion and it is not full, again rear value restarts with 0. Now again after 7, again rear value becomes 0. Now this value 90 inserted. Or for example, 15 inserted, consider. again. Next, again what? In the next iteration, rare value minus 1 fail. Rare equal to size minus 1 fail. Again, rare plus plus. Last one is a rare plus plus. Nothing but rare value become 1, 25 inserted. Rare value become 2, 35 inserted. Rare value become 3, 45 inserted. Rare value become 4, 55 inserted. So, the rare value become 4 consider. 4. Now observe. This is the second condition you need to check. This is the second condition. Still Q is full. But this condition failed. Front is 0 na? No. Rare is size minus 1 na? No. But still Q is full. Still Q is full. See, rare value 4, front value 5. So front and rare side by side are there. Side by side are there. Is a 1. Then what will happen? Simply, you need to add one more. Or either that one or this one you have to check. So what is this? Either front equal to rare plus 1 or rare equal to front minus 1. Or rare equal to front minus 1. Anything you need to check. This is the way. Whenever we are checking that, two conditions we need to check. How many? Two conditions we need to check. Because two situations will come, not one situation. Two situations will come. Now, sir, come to deletion part. Again, sir, I'm deleting the fifth location element. I'm deleting that fifth location element. 5 becomes 6. Sixth location element. Seventh location. Suppose sixth location element up to here. Now it will become 7. Now it will become 7. Sir, now I want to delete this seventh location element. I want to delete this seventh location element. Not a front plus 1. It's the same story. It's the same story. Else if when front value reaches size minus 1 at the time of deletion. Okay, here front again starts with 0. Front again starts with 0. This is the one. Hope you got it. That is. Next, sir, again I'm deleting. Look at this. It reaches this. Now, sir, I'm deleting this. Front value become 1. I'm deleting this. Front value become 2. I'm deleting this. Front value become 3. I'm deleting this. Front value become 4. So I can keep on deleting. Front value become 4. Now observe this. Rare value 4. Front value 4. I already told you that whenever, see here I explain. Whenever front and rear both are equal, when this position will come, that means that Q has only one element. That is the last element in the list. That is the last element in the list. Is a 1. So simply to understand how we need to explain, right? How we need to explain, very easy. This is the code, this much we have discussed now. But only one point you just remember. Only one point. In the circular queue, suppose this is the entry point, this is that last, is the first location, and this is that last location consider. Is a last location consider. Only one thing in your mind. First insertion in the first location, we keep on inserting rare plus plus, rare plus plus, rare plus plus. When rare reaches size -1, again it will start from 0. First insertion from the 0. Next, 1, 2, 3, 4, 5, 6, 7. Nothing but whenever it reaches that last location, again it will start from 0. 1, 2, 3, 4. Like this it will move. Deletion also same. First deletion from first element. Then it will go friend plus plus, friend plus plus. When it reaches size -1, again it will start deleting from that. Easy. And now only one thing you need to do now. That is, here it is. Suppose in this one, the two situations I have already shown you. I have already shown. Insertion, deletion, I have explained completely. Now, display code you have to write. Why? Because display code means what? Display code. The first situation I already told you. It's a 0th location. It's a 7th location. The front is pointing to this. Some elements are there. 10, 20, 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Suppose 60 is there. 60. And this is the rare value pointing. Is a rare value. 0, 1, 2, 3. 0, 1, 2, 3, 4. 4 and 5. If rare value, nothing but if front value is less than or equal to rare value, using one for loop, you can display the elements. Simply I'm writing here. Using one for loop, nothing but repeat the loop from front to rear, just like a linear queue. You need to display the elements from front to rear. But one more situation I have shown. The second situation, after some deletions, okay, that front is there. First, suppose full is there. Full 10, 20, 30, 40, 50, 60, 70. Starting from 10, 20, 10, 20, 30, 40, 50, 60, 70, 80, 80 is there. After that, suppose if you delete some elements, delete means what? Automatically front will move. Na? Suppose this one you deleted, this one you deleted, this one you deleted. Consider this one you deleted, this one you deleted. Now this is the front location. Because after deletion, it will go to that one only. Front equal to 5. Front equal to 5. So 5, 6, 7 location elements are there. Now again, I keep on inserting. So rare value will come to 0th location. Rare value will come to first location. Rare value will come to second location. Rare value will come to third location. This is one. So in this case, this is rare. This is rare. Now front value is not less than rare. Rare value only is less than front. In that case, two loops you have to use. One loop is for printing. One loop is for printing front to size minus 1. Second loop is for printing 0 to rear. Two loops required. For printing these elements, one for loop is required. And printing these elements, another for loop is required. So in a else block, that is if block, na? That is if block. Here it is a two loops required. This is from front to size minus 1, I'm writing. And this is for 0 to rear. 0 to rear. Using this knowledge, almost I have explained. Only what I'm expecting is what? Just write the code and draw. Check whether it is executing or not. Simple thing. Okay. You can leave for today. Same if you practice this one, DQ is easy. DQ I'll explain somewhere in the middle so that circular queue recall by the time. Tomorrow I'll start single linked list concept.